continue in this world of volume. And here's just a quick little aside. Let me draw a quick picture on the side over here. So here's some function f of x. And we're going from a to b. I mean, I hope this is not a big deal. And then I'm going to have some line down here that's my axis of rotation. I'm just going to call it y equals k. Whatever, it could be anything. If y equals k is my axis of rotation, and if I'm taking the region bounded by f of x from a to b and the x-axis, and I'm revolving around this, I just want to make sure we've got the big picture in place again. The first question that you need to ask yourself, that very first question,
solid or hollow?
Are you going to have a solid object or are you going to have a hollow object? Right? Solid or hollow? Do you have all of it or is there going to be a piece missing? In this case?
Solid. Piece missing. Hollow. Hollow.
Solid.
Y equals K.
Look at your axis of rotation. I didn't say spin around the x-axis, I said spin around this line. Hollow. There's a piece that's missing. So as soon as you know that the volume is hollow, now the weird thing is sometimes even the College Board says find the volume of the solid of revolution, even though it's hollow and we get a little confused. Well, it's hollow, then right away I know I'm doing an integral, pi, and then it's going to be big radius squared minus small radius squared, because with hollow objects you always have to do a subtraction. Okay?
Yes, sir.
All right. So then you're going to look at your little rectangular slice and you're going to say, okay, well, here's my rectangle. And let's see, what happens with this rectangle? It gets spun around this line, and it's like whoosh, whoosh, whoosh. All I'm going to do is I'm going to take this rectangle and reflect it over the line, and so I get another rectangle down here. Okay? And if you want to think about the 3D piece, you're just going to connect these two with the little hoop, and you're going to connect those two with a little hoop. I don't go all the way around because then it gets confusing and busy, but there's a piece, there's its reflection, and then the object that I get is a washer, right? Well, what's the big radius? The big radius, you're going to start on your axis of rotation, and tell me when to stop. Do I stop here?
No.
Yes, sir.
Here?
No.
Yeah.
Right, that's your big radius. The length of that big radius, you want to say, well, I started on the line y equals k, I ended on the curve f of x. How long is the big radius? How long is that?
K minus K plus F of X.
K plus f of x? K minus f of x? Think about your geometry experience, maybe not for too long. Okay, how long is that slice?
F of x plus
Not f of x plus k. Top minus bottom.
Oh.
So the big radius is f of x minus whatever this k value is. Now what's the small radius? The small radius goes from here to your x-axis. And so that's your small radius, and it's going to be 0 minus k or negative k if you want to go with that. So then your setup becomes f of x minus k the whole thing squared minus negative k the whole thing squared. Pi, now our integral, we're going to go from a to b. Big radius squared minus small radius squared dx. And then from there you pop it into the calculator, you do it by hand. What else? Are we mostly okay? Okay. I think some of you are getting a little tripped up with this whole the y equals k, but it's below the x-axis. Well, k could be a negative number. K could be like negative 3. Then you'd be saying f of x minus negative 3, which is f of x plus 3. It's all going to work out okay. Henry, then Abel.
Do you know all the problems in the first quadrant?
Not always.
Or like most of them?
Okay.
Are they going to be like on the fourth?
Absolutely. Anything's possible. It's also possible that your axis of rotation isn't down here. It could be up here. And you could take your region and spin that way. It's possible your axis of rotation is vertical and you're spinning this way. We're going to get to that today. We didn't, with you guys, I don't think we get to that yesterday.
No.
But it's going to be okay. All right, so show me what you can do with this first one. I want you to go completely on your own. Okay, Zeus, if we could switch over here. I'm only going to give you about 4 minutes. In this first 4 minutes, I want you to read. I want you to make sure you understand the region. I want you to take action. Do as much as you can in the 4 minutes, but you're going completely on your own. I want to be a proud papa. That's fine. No, there's nothing. Jude. Yes. Yeah, you are all five, ready? I'm all done. Okay, perfect. You're good. Hold on about. Yes, sir. This guy here is the slice that you're spinning. That's what makes the washer. So if we're gonna the rectangle is like the middle piece. Right, so take this perspective. Right, we're spinning it around that way. But the big radius, you go from the center all the way up. The small radius, you go from the center to the end. Not necessarily. It's going to depend on what you're spinning around. Make sure you understand the region. Michelle's off to a good start. Paul's off to a good start. Your son looks like he's off to a good start. Jesus is looking good. Jalissa is there. And for the folks at home, region R is the portion of the xy plane bounded by the curve f of x equals the square root of x. Okay, that's a friendly one. I don't need my calculator for that. The x-axis and the y-axis and the vertical line x equals 9. That's the region. Determine the volume of the object formed when region R is revolved around the line y equals -2. Here's y equals -2. That's what I'm revolving around. Now, unfortunately, College Board is not going to give you any points, not even one little point for the graph, but the graph is where the magic happens. Love it. Okay. Copy and calculate. Yep.
So like, let's say we were doing area, that's just that was
Well, if it was area, Henry, if I was only looking for the area of this piece, then we wouldn't even have an axis of rotation that we're talking about.
oh yeah.
Right? Alright, see a whole lot of good things. If I just get a little practice with my drawing here, I take my rectangle, that rectangle spins, here's its reflection down here. Every time I do this, I want to thank Miss Blakely at East End who taught me how to draw these things. I think we're doing okay. Hollow or solid?
Hollow.
Hollow, good. Okay, volume, hollow. So this is going to be pi, an integral, big radius squared minus small radius squared, because that's how we work with the washer. When you're determining the radius, you always start on the axis of rotation, whether it's here, here, or here. So you just go and boop, big R. Boop, little r. How long is big R? Big R starts down here, goes all the way up here.
F of x minus.
f of x
Minus 2. No,
minus negative 2. Right? Or if you want f of x plus 2, that's fine. How long is the small radius? 0 minus negative 2? 2. So f of x plus 2 the whole thing squared minus 2 squared. Integrate from 0 to 9. How many of you guys honestly have that as your setup? Seeing a whole lot of folks. Great news. I am probably going to award 2 points, and this is what the College Board normally does, because you've got this part right. You got the integrand set up. You're going to get another point because you've got pi in the limits of integration correct. The last point, if it's calculator active, what's that volume going to be? And you're just going to type it into the calculator, and I want everybody to make sure you get these skills. Because that's where you start your revolving, and this is where you end the revolving. Okay, it looks like Yvelle's got 1,272.345. Anybody else? Okay, no one else seems to agree yet. Okay. Jesus has 353.429. Michelle's got 353.429. Destiny's got 353.429.
I don't know how I got. Yeah, I got
353.429. Okay. So one more time. How many of you guys had the setup right? Seriously, the setup is going to be the majority of the points in a problem like this. This is where the money is. After that, it's like, can you type it into the calculator? Jeanette?
Are they going to take points off for units?
No units are usually given in a problem like this, so don't worry about units. There could be units. Now, here's where I want to make sure that we can get a little bit of practice. You might see this on the calculator inactive part of the test. So put that calculator away. I want to get you some practice with the calculator inactive part. Yeah. So I want to say this is challenge by choice. If you feel good with your integration skills and your evaluation skills, go. Go, finish it off. If you want to just like stay with me while I work through this, that's fine too. Where are the folks that are going to stay with me? I want to know who I'm looking at. Everybody else, you're going solo with the integration without the calculator. All right, so first thing I'm seeing here, square root of x plus 2, the whole thing squared minus 2 squared. I have to do some work here. I'm going to have to do some algebra work. Yeah.
I have a question. Why is it 2 squared instead of negative 2?
Because when you're doing the distance, it's top minus bottom.
Oh.
0 minus negative 2. Lengths should always be positives. All right, so back over here. Square root of x plus 2, the whole thing squared. Well, that means square root of x plus 2 times square root of x plus 2, and be careful here. You're going to want to do the box. When you do the box, square root of x plus 2, square root of x plus 2, square root of x times square root of x is x. Square root of x times 2 is 2 radical x. 2 times square root of x is 2 radical x, and 2 times 2 is 4. So I've got pi times the integral from 0 to 9 of x plus 4 square roots of x plus 4 minus 2 squared is 4. And I'm going to integrate the whole thing with respect to x. Other things I can do here. The 4's are going to cancel out, hopefully not a big deal. So now I've got pi times the integral from 0 to 4 of x plus 4 square roots of x. For the folks that are with me on this problem, how are we going to integrate this? Sheila, what do you think?
We have 4 squared of x squared and 3 roots right as 4 x.
Okay, right. So I heard you say 4th root of x, but it's not 4th root of x. This is 4 times the square root of x. Okay. So you're right. We're going to rewrite as x plus 4x to the half. And the reason that we just did that, you want to use your power rule. The integral of x, I'd hope, is pretty standard at this point, 1/2 x squared. The integral of 4x to the half, add 1 to the power, so you get x to the 3/2. And then divide by the new power. So 4 divided by 3/2 is 8/3. Everything gets multiplied by pi, and you evaluate from 0 to 9. I don't know how you feeling about this. What are we going to do next? I don't know.
Don't you have to big parentheses minus parentheses?
Yeah, we're going to do the evaluation part. Let me write it up here so I'm not like kneeling on the floor. Okay. So big parentheses minus big parentheses. We've got pi times 1/2 of 9 squared plus, I think I need bigger parentheses, 8/3, 9 to the 3/2 minus pi, and we plug in 0. Oh, what a kindness. 0. So really the only work to do is right here. 9 squared is 81, 1/2 of 81 is 81 over 2. 9 to the 3/2 means take the square root of 9, that's 3. 3 cubed is, what is that, 27? Times 8/3. Well, 1/3 of 27 is 9. 8/3 is going to be 72. If you get a common denominator, I think you're going to get 225 over 2 times pi. I know I went a little fast with the plug-in and the simplify, but that's not calculus stuff. That's should be a little more algebra. Okay. So I'm going to leave this up here. You want to look at it when you talk about it, that's great. What I want to do is give you guys the next 10 minutes. And specifically, I'd like for you to look on pages 20 and 21. Scratch that, just 21. Just 21. Okay. There are 4 problems here. The first 3 are calculator inactive. The last one's calculator active. Some of these are going to be relatively straightforward. Some of these are going to be more challenging. Challenge by choice. Go where you want. I also want to draw your attention to page 22. For those of you that struggle maybe with the visualization piece, I've already included the graphs for you of what does the flat region look like and what does the volume when it gets revolved look like. I just want to give you guys 10 minutes to work in your groups, get as many of these done as you can. If right now you want to focus on the setups, like this first part, that would be, I think, a good place to start the time. We get 10 minutes. Use the time wisely. It's not your calculator's fault that you don't know what you're typing in. You were supposed to type in the square root of x plus 2. And you typed in square root of x squared. Okay. So it's not this calculator, it's this one.
This one.
Sorry if I messed with the curls. And feel free to talk to these smart people around you and get some help from them. Paul, in a little bit, are you going to be in a position to drive the calculator?
Yes.
All right. Make sure you know what the region looks like. So sorry.
Yes.
Sorry, we're gonna get bad math. See bad math, I get clumsy.
Except I wouldn't want to see you divide
By
by
x. If x squared is equal to 2x, the better thing to do is to get everything on the same side instead of equal.
so that now you can factor. You're revolved around the vertical line x equals pi, so I think you need to get into what the graph looks like first.
Okay.
Wait, so I did x squared equals 2x, right? And then x squared equals
I just have to equal to
and then x equals square root of x square root of 2x.
So when I
X
think
squared
about spinning around the x-axis,
2x, right? And then the square root of both sides take away the square.
there.
Yeah, x equals 2x. X equals square root. X equals 1. Because what other number can you find there? That one. Plug in x equals 1. 1 equals
Yes. That looks perfect.
Except what you need is big for a hollow object, it's big radius squared minus small radius squared. So big R squared minus small r squared.
You know what I mean?
In the calculator, you need to plug it into the y-axis.
You're gonna need. I think it's. I want to see you like mark up the facts. I think you're trying to memorize something. I think it would be clearer if you like sketch it right. So you're gonna cosine x. Show me the vertical line x equals pi. Yeah.
But I would be the big R.
So you're looking at that guy there?
Yeah.
Oh, look.
Here's your axis of
I think it
rotation.
was easy the other way.
And you're spinning that
So
way,
you,
right?
you do the equation.
Where's the big
radius? You would x squared equals 2x. You divide the x. X squared divided by x.
Where do you start?
So the radius,
Right.
you're measuring
Yeah,
from
I was
the
gonna
axis
Pi, right?
until you hit the outside
Why is it
curve.
not equal anything?
That's the big radius. The small radius, you start on the axis and you go to the inside curve. So how long is the big radius? The length of that slice. This is why I want you to draw it. How long is that slice? Top minus bottom.
Oh, okay. And then the small one just be the bottom next to it.
It's going to be top minus bottom again to the bottom. The big radius is 2x, the small radius is x squared. Okay, hold on. Yeah.
Okay. Find the volume when that and the x-axis and the y-axis. So what region are we talking about? Just that region is spun around that line. So when you're spinning around that line, get a marker here. If you're spinning around this line, your slice is going this way. So everything is dy for all. Whoa. Okay. No spheres. No spheres. Just because it's curvy doesn't mean that when you spin it you get a sphere. Yeah. Yes, ma'am.
I tried it first and
So the big R starts on the axis of rotation and goes to the outside curve. How long is that? Right, if you're determining length, it's top minus bottom. What's the top function?
I'm missing
2x minus what's the bottom? 0.
I'm missing 6. I have it, I just don't turn it in.
If you're small radius, you're going to start on the x-axis and go up to the parabola.
It's because no, I know what happened when I hack on the phone. It's not it's from the last week. So I clicked on top and changed the weight to 8.5 and then hit refresh. No, like most of your colleagues doesn't appear when I'm missing. No, like section 2, you go to the exact it appears
2x squared equals 2x times 2x, which is 4x squared, which makes that 4. So when you're doing small objects, big radius equals small radius.
I'm going to
Yes, try them both. Right. Big radius squared minus small radius. It's, and that is not the same.
It's hard to paint level 1. Level 5.
All right, Paul.
No, not necessarily. Anything could happen. Which is why I want you to take the time to sketch the region so you know what you're looking at.
All right, friends, it's time for a push. Okay, you could flip over to page 23. I don't think we're going to get through all 3 parts. We've only got about 15 minutes left. We've got Paul in the back who's going to be doing a little bit of driving on the calculator. This is fair game when it comes to the AP exam. This is fair game when it comes to the quiz on Monday. And I'm not going to do this to break you. I'm going to do this to push your thinking a little bit more. So I want to give you guys a minute. Read through the problem. Make sure you understand what you're looking at. And get everything set up on your calculator so that we're ready to have some conversation. All right. And Gonzalo, if you could turn the front light off. And Paul, do you do me a favor, can you go to the home screen? And from now on, stay on this side of the screen, stay away from the documents part. Okay? So get your graph set up, get all the things, make sure it looks the way it's supposed to look. Let me see if I can zoom in a little bit more here. Get everything graphed on your calculator. I'd also recommend that if they give you a graph and you see, like I see on Michelle's, I can see for Paul, that although they've graphed the right things, it doesn't look like what it looks like on the paper. Fix your window so that you see everything. It's going to make life a little bit easier. So maybe go from negative
Or go from like 0 to 0.6 or 0.7, whatever looks good to you. Give me a quick thumbs up when you've got these graphs showing up on your screen. All right, part A, set up but do not evaluate an integral expression which can be used to determine the volume of the object when region R is revolved around the y-axis. Region R. Region R is this guy here. What are we revolving around? Where's the axis of rotation? Y-axis. Can you guys show me that with your arm? Y-axis. Y-axis, we're going this way. You're spinning this way. I would hope you start to worry a little bit now. Why are we going to worry?
If we haven't done that,
We're not spinning around the x-axis or a horizontal line. You're spinning around the y-axis, right? So what's going to be different here, Flora? What's going to be different? You're going to have to change the function. We're taking this region here and spinning around that line there. Solid or hollow?
No, solid.
Solid or hollow?
Solid.
Solid. This is absolutely solid. This region touches the axis of rotation the whole way. So already I'm thinking, okay, well, volume, it's going to be pi. There's going to be an integral. Solid. Okay, so that's stuff squared. dy or dx? Has to be dy. You know it has to be dy. So we're going from y equals place to y equals place. In terms of y. Great. We're off to a great start. There might be some pity points. Okay. Somebody take it from here. What else do we need to know? Just Paul? What else are we going to need to know here? Gonzalo, what do we need to know?
You need to find the intersection point.
Okay, you want to find the intersection point? Why does that seem important to you?
Because well, you're gonna look at it from the other, like you're gonna tilt it a little bit. So then you're gonna it's gonna be an integral from the 3. Wait, never mind. Never mind.
Okay, he's on to something. Marilyn, help him out.
You also need to know where each graph intersects the y equals 0.
Okay, you want to know where each of the graphs intercepts the y-axis because these are going to help you figure out your limits of integration. Now, hopefully these are friendly functions. You can do it in your head or you can do it on the calculator. Doesn't matter to me. Okay, do we know the intersection points?
1 and 3.
Okay, so this is 0, 1 and this is 0, 3. Okay, now Gonzalo said he wanted to find the intersection point as well. Sure, maybe. Let's go find the intersection point. We might need that. Might need it. Okay, according to Paul, we've got 0.3442 and what number is that? 1.1410.
Yes.
Hopefully we're okay. We've got an intersection point here. Now the next thing I always start to think about is I start thinking about those rectangles, right? Those representative rectangles. If I draw this rectangle, how long is it?
F of x minus q.
Minus y.
You want to be careful. We're going horizontal. Not top minus bottom, right minus left.
X minus y. F of x minus.
So is this guy here, is this g of x, the red one? Or f of x?
G of x.
G of x.
G of x. And this guy over here is f of x. Now, what I just heard a lot of people say is, oh, so g of x, and g of x is with 3 cosine pi x? If you say 3 cosine pi x minus 0, we have a problem. What's the problem? What's the problem? If you say 3 cosine pi x minus 0, what's the problem here, Flora?
It gives you the y value, so you would have to look for the x value.
What you need to do is everything needs to be in terms of y. So you're going to have to do a little side work. And some of you asked me this earlier, like, oh my God, how do I solve an equation like this for x?
what are we gonna do?
Oh, divide by 3.
Divide by 3, y divided by 3 equals cosine pi x. And then it might be this next piece that gets a little wonky.
Arc.
How do you get rid of cosine?
You don't.
Yes, you do get rid of the cosine. It's arc cosine. So arc cosine, or inverse cosine, is going to be pi x. So what's x? X is 1 over pi arc cosine of y over 3. That's this boundary right here expressed in terms of y. So that now when you say right minus left, the right curve is this 1 over pi arc cosine y over 3. What about the left one? Y equal the y-axis. What is that? That's 0. So how long is your radius? It's this 1 over pi arc cosine y over 3. So 1 over pi arc cosine y over 3 squared. What we haven't done though, we haven't talked about limits of integration. From where to where?
From
1 to 3?
1 to 3?
No,
Negative
negative 3.442.
Okay, hold on. A lot of people said 1 to 3 in the beginning. And I would think 1 to 3 is going to be a popular wrong answer. Destiny, do you know why it's going to be a wrong answer?
Well, because your rectangle is going from left to right. I mean right to left, and so you need that intersection point over there, that 0.34 to 3, because I don't know the reason.
Okay, the intersection point is important, and the reason that it's important is that you switch. You switch what your boundary is. When you say right minus left, what's on the right? Well, it's g of x in the beginning until you get to the intersection point. After the intersection point, what's on the right? The graph of e to the x. So the way you determine your radius has changed on you. So you're going to say it's in terms of y, 1 over pi cosine y over 3 squared. Oh, what was the y value there? 1.14. So 1.410 to 3. That's going to give you the volume for above the line. Take a minute, get me the volume for below the line. I want to make sure everybody's okay with this part. No tissues needed.
So now instead of using the x, you just use the y.
No, we're doing the.
When you do a dy, it has to be that way. Rectangles down here start on the y-axis and they go over to y equals e to the x. Y equals e to the x. I can take the natural log on both sides. And so natural log of y is equal to x. Your other integral is pi. You're going to integrate from 1 to 1.410. How long is the slice? Right minus left. So natural log of y, the whole thing squared dy. How many guys have that as your setup? The other one. Okay. So we're done?
No.
Subtract them? Add them? Right, what we found was like the volume above the intersection point and the volume below the intersection point, and now I'm going to add those two together. On this particular problem, we're not interested in what the number is, just the setup piece. All right, see what you can do with part B. I think part B is going to be a little kinder. Yeah. No. Don't think X's do this, Y's do that. Think, what does the geometry tell me to do? Right, because I wanted to find the volume for this whole region.
Hit me up on YouTube.
And the issue is the way you determine the radius changes if you're above the intersection point and if you're below the intersection point.
find the volume, add them together here.
Miss, are you gonna have lunch support on Monday?
What?
Are you gonna have lunch support on Monday?
I won't even be here on Monday, remember?
Oh yeah. How about Tuesday?
Tuesday, yes.
Okay. I'll leave it. Yeah, I need the ultimate.
He whispered in my ear.
Make sure you know what region you're talking about in part B.
Wait, the part we were doing was part A?
Region is.
We were on part A, yeah?
I don't know what part A we're on. Look. Esta me sale que escondía el
For all the folks in the room, are we good that we're spinning this region, the bottom one now, around the x-axis? Solid or hollow?
Solid.
That seemed pretty consistent. Solid. We got solid.
Yes.
So if this is solid, now dx or dy?
Yeah.
Right? You're spinning, you think about your rectangles this way, and for most human beings on the planet walking around, these are safer ones, right? This should be more comfortable.
Yes, sir.
Good. Okay, so pi, an integral, something squared dx. Well, what's the radius? What's the height of the rectangles?
EX.
Yes.
E to the x?
Yeah, that.
So e to the x squared, and then we just go from 0 to whatever this point is over here.
0.3.
I think this intersection point is at 0.5.
Yes.
So how many guys are going to say go from 0 to 0.5 and you're done, you're good? Jackie was like, no. Popular wrong answer is going to be to go from pi to 0 to 0.5. Want to get some hands on this before the bell rings. What's wrong? What are they not thinking about? The kid that says integrate from 0 to 0.5. Jackie, what's wrong? What are they thinking about? They're forgetting that at the intersection point, it switches. The way that you find the height, all these rectangles over here are f of x, but all the ones over here are g of x. So the right answer, what was that intersection point? 0.342 plus pi, and then you go 0.3442 to 0.5, 3 cosine pi x squared dx, and I realized nobody had time to pop it into their calculator, but I hope the setup on that is starting to feel more comfortable. All right, friends, I will see you on Tuesday or today during lunch.